For our governor today, we are being reminded of what we worked on yesterday, where we're applying our properties of exponents, but they have fractions. We have to remember our properties of fractions to make that happen. So remember, we always start with your coefficients, and you apply whatever operation is already being applied to them. So this is being multiplied, so 3 times 4 is 12. Now, the product property of exponents says that if we have two bases being multiplied, we can add the exponents. This is like 1 over 1, negative fraction. So if I have 7 over 4 plus 1 over 1, I want a common denominator, because when you add fractions, you must have a common denominator. So I'm going to multiply this 1 by 4 over 4, so I have 7 over 4 plus 4 over 4, and that is 11 over 4. So I have 12x to 11 over 4. Since 11 over 4 cannot be simplified nicely, we're just going to leave it as an improper fraction. In number 2, I'm going to apply my power to a power property, which means I'm going to multiply my exponents. So I have 2 over 1 times 4 over 3. With multiplication, you do not need a common denominator. I'm just going to multiply straight across. I'm going to get n to the 8/3. With the quotient property, then I have 1 over 1. I'm going to subtract my exponents. So I'm going to take 1 over 1 minus 1 over 4. Gotta have a common denominator for subtraction. I'm going to multiply this 1 over 1 by 4 over 4. I get 3/4. So my answer, remember when you do quotient rule, your answer automatically goes to the numerator. M to the 3/4. In number 4, I'm going to start with this 2, move that out front. It doesn't have anything to multiply with it. So I look at the u's. I have 1/2 plus 3/2. Those already have a common denominator, so I'm just going to add straight across. 4 over 2, that's 2. So I'm going to say 2 u squared and 2/3 plus 4/3 is 6/3, which is also 2. Now today we are taking a step in a different direction, and we are talking about converting between rational exponents and radicals. And rational exponents are what we were just looking at, where we had fractions. Rational is just a fancy word for fractional. And radicals involve a square root symbol, or a root symbol, not necessarily squared. So we've got some guidelines here. The number outside the radical. So this is a square root. So we don't use it. It's sort of like when we have x to the first, we just call that x. With square root, there's actually this invisible 2 there that we don't have to put because it's already known to be a square root. So this number outside, it's called your index. Inside, underneath the radical, you've got your base. Here up to this too. And your exponent. The base and exponent are familiar. We've been working with those. So we can flip-flop back and forth between radical and rational functions. So if I have the square root of x to the 5th, I can convert that to a fractional exponent. What we're going to do is I'm going to rewrite my base, so I've got my x, and then the exponent, which was 5, is going to move to the numerator of your fraction. The index, which was 2, is going to move to the denominator. So the square root of x to the 5th can be rewritten as this x to the 5/2. So, this is actually asking me to go backwards. Okay, so here is what's going to happen. If I'm wanting to go, so I want to get this in a radical, so I need that root function. I'm going to write my base, which is 5. My numerator moves to the exponent. My denominator moves to the index. So this is the cubed root of 5 to the first, or just the cubed root of 5, because we know 5 to the first is the same as 5. So I do the same thing here. Put my root in. I'm going to put my base in. My numerator moves to my exponent. My denominator moves to my index. If I have a quantity that is not just one term, I'm going to include that whole base. So 2x is my base. I'm going to keep it in parentheses. My numerator goes to my exponent. My denominator to my index. So number 4 will look like this. Or you could not even have the 1. Just call it the cubed root of 6b. Because we know that anything to the first does not need to be written that way. So all we're doing is rewriting. We aren't solving for anything. We aren't really simplifying. We are just rewriting so that it's in the radical form. And radical means it has that root. So I want you to try these. So go ahead and pause this now and just check these for your answers. I am only going to write answers. If you are struggling with this, in a few minutes I will be doing this with your peers in class, so you can pause and go through this with me then. I'm just going to write answers. Now, let's go backwards. So this time I have my expressions in radical form. I'm going to get them in rational form. Rational, remember, means fractional. So if you don't see an exponent, remember that means your exponent is a 1. So I can write this. I'm going to write my base. My exponent is going to move to the numerator. My index to the denominator. So the 4th root of 5 to the first is 5 to the 1/4. Now if you don't see an index, that means the index is 2, because this is naturally called a square root. So this is going to become my base of 7. My numerator is going to be 3, that's my exponent. And my denominator is going to be 2. If I look at C, this time my base is more, so I'm going to go ahead and put my base in parentheses. My numerator is going to become, my exponent is going to become my numerator. My index is going to become my denominator. Remember, if I don't have an index, that's 2. This is going to become x to the 5/2. So again, we are just rearranging, not solving, not really simplifying, just rearranging. So I want you to try these yourself. I'm just going to put answers up for you. Once you've finished, you have the rest of the time to work on homework.